Okay, thumbs up if you can hear me. Just awesome, good. This is really weird. I can't hear my own voice in any speakers, but I'll get used to it, I guess. So it's supposed to start 20 past, but I have a lot of slides. I thought I'd get started already, and I'm guessing you got that I like cats. So let's get started. I'm going to talk about Kotlin Coroutines, how we can use those to create some better async programming on Android. My name is Erik Hellman. I'm very happy to be here again. I was here last year. It was a blast. This year, I decided to go for a presentation that doesn't require any network. So yeah, I learned from last year. If you want to check out the slides, I've already uploaded them on the speaker deck, so you can find the link there. You'll see the link also in the end of the presentation. OK, so let's get started. Async, or asynchronous programming in general, is really hard. It's one of those things that I've noticed most developers struggle with. Anything that requires callbacks or listeners or anything like that, it's usually something that we make a lot of mistake with. I do a lot of teaching, both beginners and advanced developers or more senior developers, and I noticed that this is a recurring challenge for most of them. So I was very happy when the coroutines came out and I started looking at that. I said, like, hey, this is actually what can solve this thing, what can make it much, much easier. Perhaps not complete solution for it all, but at least make it manageable in a different way. So why is it a problem? Why is asynchronous programming so hard? Well, it all boils down to the fact that we suck at multitasking. All of us are horrible at it. Nobody who claims they are good at multitasking knows what they're talking about, because we know from science that we can actually only manage to keep about 5 to 7 things in our head at the same time. So if you ever have more than that to keep track of at the same time, you will start forgetting things and make mistakes. So if we are bad at multitasking, that means also when we write our code and we need to keep track of all the things that happen on different threads, that will also generate mistakes. So we need to make this simpler. We need to have fewer things to think about when we are programming stuff that happens asynchronously. So let's take a simple example. We're going to return to this one all the time during the presentation, so I'll explain them here. You have 2 functions. These are synchronous functions. One is for loading tweets. It will go out on the network, fetch the tweets, and return a list of them. Maybe you're using retrofit and Moshi or whatever. It doesn't matter. It's implementation details, but the fact is that this is a synchronous method. It needs to run on the background thread, so I annotated it with a worker thread annotation. That's a hint to Android Studio and Lint, saying that if you try to call this on your main thread, you get a warning. It will also probably crash on most phones because strict mode and all of those things. And then we have our show tweets method, function, sorry, that is annotated with main thread. This is the one where we update our UI. Maybe it's we assign the data to an adapter and call notify dataset changed, or something like that. But it needs to run on the main thread. If we try to run this on the background thread, the same thread that we call load tweets on, we will crash. So this is the basic problem that we keep having. Now, there are many ways to solve this. So those of you who have been doing Android for a while, you're probably using AsyncTasks. You're probably, hopefully, not using AsyncTasks still. But this is what it would look like if we would do it in Kotlin. You extend from AsyncTask, you provide in the parameters, you call the thing in the background, and then you get a callback on post execute with your result. It works, but it's cumbersome to work with. You need to make it an inner class in order to be able to call the methods in your activity on other places, and it's basically it's not a very nice way to do asynchronous stuff in general. So the Android community as a whole tried a lot of different things, and over the last couple of years, RxJava has come up as the solution to all these things. So we do something like this. We create a single from a callable, where we call load tweets. Then we say that please do this subscription on an IO thread, so it happens in the background. OK, done. And then we go over to the main thread. We observe stuff there, and then we subscribe to these things. We have a disposable that we can call dispose on, when it's time to cancel this one when our activity gets destroyed, so that we are not trying to update the UI when we shouldn't do it. Now, this one has also a nice way to handle errors, so we can provide another callback function in the subscribe there saying, okay, in the case of an error, do this. This kind of solves it, but there are lots of things here that we really shouldn't have to care about. The jumping from the IO thread to the main thread is one thing, and the division of the error and the showing is, can be a little bit weird for some developers as well. Also, it requires you to have an intimate knowledge of RxJava, something that has proven to be a challenge for a lot of developers. RxJava is great, but it's not easy to grasp. So what we really want is something like this. We would just be able to call this load tweets, get the tweet, and then call show tweets, where we pass in the result. We should be able to do that. It's 2018. Why can't we, why do we have to care about all this asynchronous stuff? And I mean, this is how everything else we work with in life, usually how we approach it. We're thinking sequentially. If you read a recipe, you're going to cook it. Take one thing at a time. Even if there are implicit asynchronous stuff happening, you put something to boil, still written like one sequential sequential list of instructions. So we can't have this, unfortunately. It's not possible to go exactly like this. But what we can do is something almost like that. So this we can do, and stay tuned, and we will learn how. Coroutines, that's what this is about. What is it? Well, if you would boil down the definition, it's a state machine and a queue. And that's basically it. Then there's some stuff behind the scenes for launching them on different threads and handling them and doing other things. But basically, this is what coroutines are about. Coroutines are a really old concept. It's actually older than both multiprocessing and multi-threading. It came out in the late 50s, and the first implementation was from one of my favorite programming languages, COBOL. So it's been around for a while, and it keeps coming back in many different forms. But this is the first time when it comes to Kotlin when I see that it's actually useful and usable. But you see this thing, you see this definition here, and you're probably still like, what? What is this? That doesn't say anything to me. We're talking asynchronous stuff here, doing stuff on background thread and then foreground thread, so yeah. So let's try a different analogy, see if we can describe this in a different way. Everybody knows this picture. We probably also hate it. But this is a very good analogy for what coroutines are and how they work. An activity is something, it's a process that the user starts, and they do stuff in there, and it can be suspended, paused, stopped, saved in the background, and then resumed again in the same state. That's very much like how coroutines work. So you probably have something like this in your code. You have the onCreate method. You should probably here check what saved instance state has and restore the state from that one in your application. And then you have the onSave instance state, where it's a signal to you to say, OK, it's time for me to shut down. Here you got something where you can store the state of your application. So this is something we've been doing now since the beginning of Android, basically. And it works well. And this is a good analogy. So if you think of activity as a process that the user is doing, and a bundle as a state of your application when it is stopped, destroyed in the background. Take those, and then we map them to the coroutine world. So an activity is a coroutine, and a bundle is something called a continuation. A continuation is a core concept within coroutines. Well, it's an interface in the coroutine library with 2 functions and 1 property. The coroutine context is saying how this coroutine should run. The resume will be called when you have a result from your function, and the resume with exception if something went wrong. OK, but what is it really then? So Donald Knuth, one of the founding people for computer science, basically, the guy who came up with coroutines, he said like this: subroutines are special cases of coroutines. And this was before they started using the word function instead. So subroutine is basically a function. So think of it like that. Coroutines are a general form of how to do functions. That's one way of looking at it. Water break. It's important to stay hydrated. Okay. Our first coroutine. Launch is a coroutine builder. It creates a coroutine and it starts it. In our case, we will call load tweets there, and we get the result back. It's a synchronous thing, so that line there, that will work well. Now, by default, the launch coroutine builder will launch stuff on what is called the common pool. The common pool here is a coroutine context that is built into the coroutine library. A coroutine context tells how this coroutine should run, including which thread or which thread pool it should run on. Now, we can do it like this. In our onCreate function, which runs on the main thread, we can call this launch, and it will start something in the background thread, and it won't block the main thread. Great, but first step. Also, the return value from the launch is a job. A job is something that we can cancel later. We need to cancel it. We need to be able to cancel something when the application is destroyed or when we stopped or goes into the background, depending on your use case. So cancel is an important thing. We're going to look more at that, how to handle that more appropriately. But what's more interesting is this. We can run another coroutine inside the first coroutine, and we can provide a different coroutine context, which basically means that we switch the thread that that function is running on. In this case, we use a built-in coroutine context called UI, which comes with an Android extension to coroutines, and it will basically switch over to the main thread, or the UI thread, as they call it. Now, another nice thing here, so if you do cancel on the job that is returned from the outer launch call, it will actually also cancel the child coroutine inside here. So if you define a coroutine inside another one, that becomes a child. And if you cancel the parent, the child will also be canceled. How does launch look like? So this is the definition, the function definition of the launch function. The first parameter is a context, the coroutine context. What thread to run on? Think of it like that. There is a little bit more to the coroutine context than that, but if you start with this, that's how you can think of it. The start parameter, by default, it's start immediately, start now. But you can also provide lazy here, which means that it will be started when we await this coroutine, as you've seen soon. We can explicitly specify a parent here if we want to. If we have multiple coroutines defined outside each other, we can do that. And then finally, the function that we provide to this coroutine has a suspend keyword to it, which is a new keyword coming with the Kotlin Coroutine library. And this one returns a job. So what we can do now, we can also use another coroutine builder, one called async. Instead of returning a job, it returns a deferred object. Think of a deferred object as a promise from JavaScript or a future in the Java APIs. It's something that eventually will have a value. So we can change the first call to async, load our tweets there. We will get it deferred. And then we can call launch with a UI context and pass in the deferred there to our show tweets method and call await. And this is where the real magic happens. This show tweets call happens on the main thread, but it will not block the main thread. If there is no value yet in our deferred, the await call will be suspended. That's what the suspend keyword there does for us. It will be suspended and resumed once there is a result. And that is happening using the coroutine library. So you have you have the async thing, which is launches coroutine that returns a deferred value. And then we have the launch, which is basically a fire and forget. So both are very useful, but depending on what it is you want to do, you should use them differently. A suspended function uses a continuation. So basically, when you put suspend in front of a function definition, it will be transformed to also take a continuation as a parameter. So for instance, the implementation for await here, it has suspend in front of it. The compiler will make sure that it takes a continuation there. Inside here, we call suspend coroutine function, which is a function inside the coroutine library. And when complete is a function on the completable future. So this await function here is an extension function on the standard completable future, which is part of the Java util concurrent library. When complete, when that is called, we get the result, and we get possibly an exception. So we first check if the exception is null. If it is null, well, then we have a valid result, so we pass that into the resume function. If it isn't null, then we call resume with exception, and we throw the exception instead. Oh, not throw, we pass the exception into the function. So the implementation of this continuation is managed by the compiler when it compiles your library compiles your application basically, and checks all this suspend function. That's a lot of theory about the coroutines right now. There's a lot more to read about, and I will provide you with some links later. So first, another water break. Now, let's make a DSL. So what we want to do is we want to provide that nice load then thing I showed you in the beginning. So let's start defining these functions. And these are extension functions in the beginning. So we start with an extension function on activity. So it's activity.load. We pass in a load function, which will return something of type T. Well, we start to saying, OK, just return that value. This won't work, because this is a synchronous call. So this basically doesn't do anything. So we need to make sure that we can delegate this over to the background. And that's where we use async. Now, our extension function on activity will instead return a deferred object. OK? Getting there. Now we define another extension function, but this time we define it on the deferred class, the same type that we are returning in our load extension function. And this one takes another function we call UI function, and we call launch on the UI, the main thread, and then we call await on this deferred object. So this will suspend this call until there is a result from the load call. OK. We will make one additional change to this to make it possible to do a nice DSL, and that is adding the keyword infix in front of the then function. Now, we can do the following. So with those two functions, we can create something like this. Load, do something that happens on the background, then do something that happens with that on the foreground, on the main thread. But we're missing something. We are not doing any cancellation. So if you would do this, and you would have a very long-running load call, and the user presses home, you don't have a valid UI anymore, but the show tweets method will still be called. So we need to fix that. Either we keep a reference to the job or the deferred that is returned from the load call, and we cancel that one explicitly. We could do that. You already saw me showing the code for that. But then you, as a developer, need to keep track of that everywhere. And that is something we want to try to get away from. Fortunately, the architectural components that Google has given us provides a solution for this. So what we do, we create a lifecycle observer. If you haven't used the architectural components, this might be new to you. And even if you have, you probably maybe have used Room or the view model. The lifecycle part is actually one of the core foundations of that whole library. It's a great thing. You create a class, you extend the lifecycle observer, and then you create a function there that you annotate like this. Now, when you add an instance of this class to the lifecycle of an activity or a fragment, this onStop method here will be called when that fragment or activity reaches onStop in its state. So we use that. The first thing we do, we pass a job into the constructor of this class and keep that as a parameter. And then in the onStop function, we check if this job has been canceled. If it hasn't, then we call cancel on it. Now, also worth noting here is that a job is a base class for anything returned from this. So a deferred is also is extending from job. So we can pass a deferred into this one as well. Now, we go back to this one here. Now we're calling async load function. That will return deferred. So what we do here, before we return that, we change so that instead of having the extension function on activity, we change to having the extension function on lifecycle owner, which is an interface that is implemented by both the fragment activity in the support library as well as the support library fragments, which is great. So now we can use this load function both in an activity and a fragment. Also, we get access to the lifecycle property. The lifecycle property we call add observer. We create an instance of this listener that we had, and we pass in the deferred that comes from the async call. Now, this deferred will be automatically canceled when the activity or fragment reaches onStop. So these two changes gives us free cancellation. Free, sort of. Now, we can also add some more control to this. So the one using our new DSL maybe want to control stuff a little bit further. So we can, for instance, we can have add a coroutine context parameter to our load function and give it a default context. You can create your own coroutine context like this. So in this case, I created a coroutine context that is backed by 2 threads, and I give it the name loader. And also, I can provide the start parameter and say lazy. This means that this coroutine that we call here, that we create with a async call in the load function, will not be started until we call await on the deferred that is returned. That can be convenient, depending on your use case. So that's it. We have created a nice little DSL using Kotlin Coroutines that lets us do nice things like this, load something in the background, and then do this. We get free cancellation. Anyone can understand this code who comes in, even though they don't understand coroutines. This is the power of using the DSLs, in my opinion. Now, one thing left here before I move on to the more advanced stuff, and that is, what about errors? What happens if something goes wrong? What happens if network is done when we call this? What happens if the load tweets function has an exception? So the continuation interface had these 2 functions, resume when there is a valid result, or resume with exception. And we will use that. Resume with exception. So this is what our code looks like. Now we want to catch the exception when that happens. Now, if you would use an AsyncTask, you would have to do a try-catch inside the do in background call. And that is often the thing that we would have to take into consideration. Either we do the try-catch on one thread or we do it on the other. But if we do it on one thread, how do we delegate the error over to the next thread? And this is happening. This is handled by the coroutine library automatically. So you can actually do like this. You just use try-catch, as we've always done. There is no need to have separate callbacks for error or success. just a regular try-catch. Also, again, easy to read, easy to understand for someone who's coming in and is new to all this. Now, that was basically the DSL I wanted to introduce to people, backed by coroutines, lets us do asynchronous loading in a much easier way. Wait, there is more. So let's take this. Let's say we use this in a click listener. How do we throttle the click callbacks? So even if we disable the button in the click call here, the user might actually be able to click fast or accidentally click twice, so you make 2 network calls. And depending on the situation, depending on the use case, this might be disastrous for your application. So how can you block this? Well, it turns out the coroutine library has another great thing added to it called actors. Anyone here worked with Scala or something like that has probably come in contact with actors. They exist in the coroutine library as well, so you can use them there. And let's see a very simple example of how to do that. So you've seen the 2 coroutine builders, async and launch. And async, well, gives us a deferred. But what if you want to do something where you have multiple events coming? Well, then you would use an actor. An actor is another coroutine builder. And it gives us a channel where we can offer stuff. Think of it as a queue. So we will do like this. We will create a job actor. We will have this actor running on the UI thread by default. There, we'll loop through the events that comes in the channel of this actor. Here, we call async again. We could use DSL we had, but I'm being a little bit more explicit here. So we call async, we get it deferred, and then we call show tweets, where we call await. All of this is still in a coroutine context. It won't block the main thread. The async call will happen on a background thread, so we're safe there. And then, in our click listener, we basically just call job actor offer. The unit here is that I'm not actually interested in the data I put into this channel. It's just a signal to do something, which is why I define the actor up there as unit, or void in Java. OK. So that's actors. There are much more things in the coroutine library that you can use. The coroutine library also contains stuff for doing asynchronous I/O operations, whether it's files or networks. So it's actually a really exciting thing, so I'm having big hopes for that. Question that always comes up, does this replace RxJava? No, there's a strong no to that. So RxJava's big advantage is that it has a lot of really powerful operators. You don't have these operators in Kotlin Coroutines. And this is why also there is actually a reactive library on top of coroutines that works together with RxJava. So both of these together, we can probably create a much easier way to do RxJava than we do today. But we'll see. There are a bunch of other stuff here. And you also see there is a JS library. So the coroutines thing works on JavaScript as well. There have also been a number of third-party libraries created. For instance, Jake Wharton created the retrofit adapter for the retrofit library that instead of returning a call or a RxJava observable, you return a deferred. So you can get the coroutine on top of retrofit as well. Now, how do you use it then? So coroutines are still in an experimental state. So you need to enable them like this in your build Gradle. And you need to add the following dependencies. The coroutines core is basically the core part of it. And then you need the Android part in order to run stuff on the main thread. There are lots of stuff to read up on here. I provided some links. You can find them in the slides. I have a blog post where I wrote about this a couple of months ago that you can read on. And also, I have shared that code on GitHub, so you can check it out. Now, I realize that this went super fast, but thank you all for listening. After this, I will be in the workshop down there doing a workshop on constraint layout. So if you have any questions, please come up and talk to me. Thank you very much.